So this video we're going to be solving for the turning points of a lemniscate, which looks something like this. So it could be right here, right? So there's a really simple trick which involves polar coordinates. So you know that x goes to r cosine of theta and y goes to r sine of theta. And x squared plus y squared is equal to r squared. So keep this in mind. So this is going to be r squared equals a squared of r squared cosine squared minus r squared sine squared. And this simplifies to r to the power 4 equals a squared. You can factor the r squared out, so you get cosine squared theta minus sine squared theta. And you take the square root a few times. Okay, actually before that, so this is equal to cosine of 2 theta. So you can write it as a squared r squared cosine of 2 theta. Now divide the r squared to the other side. So this is gone, equals r squared, and r is equal to a times square root of cosine 2 theta. So this is the lemniscate in polar coordinate form. And as you know, you can differentiate this. So actually, first you want to convert it to Cartesian again. So we know that x is r cosine, so r is going to be equal to x over cosine, and then we can multiply the cosine to the right side. So this means x is equal to a square root of cosine 2 theta times cosine, and y is equal to the same thing but sine. Okay, and so here, if we differentiate both sides, we get dx over d theta and dy over d theta. And to get dx, dy dx, you just divide those two. But we're setting this equal to 0 to find the turning points, so that means that dy d theta has to equal 0, and we don't really care about dx d theta in this case. So what's dy d theta? Dy d theta is equal to, okay, so product rule. What's the derivative of this? So 1 over 2 times square root of cosine 2 theta, and then the derivative of cosine of 2 theta is negative 2 sine of 2 theta, and then you multiply by sine theta again from the top, and you add a cosine of 2 theta times derivative of sine is just cosine. Okay, so we can simplify this into a, you factor a out, so cosine 2 theta times cosine of theta. Since this was a negative, we can just put it over there, and then 2 sine 2 theta sine theta. Oh, and luckily these 2's cancel out on the bottom and top, so it's just cosine of 2 theta. And we can further simplify this by, so we want to make cosine of 2 theta the denominator of this thing. So we multiply the top and bottom, so cosine of 2 theta cosine of theta over this minus sine of 2 theta. And that is all equal to 0. So Now what we're looking for is for this top part, to equal 0. So cosine 2 theta cosine theta minus 2 theta sine theta is equal to 0. And if you know your trig identities, then you will know that cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And look, this is in the same form, so this is actually cosine of 3 theta is equal to 0. Now when we're looking at the Lemniscate, actually it's up here. I'm just trying. So we notice that theta just has to go from here to from 0 to 2 pi. So we can restrict our domain to this. And that means that 0 is 6 pi. So when is cosine equal to 0? Well, 3 theta is going to equal 0. Wait, no. Pi over 2. 3 pi over 2. Then you can just keep adding 2 pi to the top. 5 pi over 2, 7 pi over 2, up until 12. Okay, now we solve for theta. Pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, 9 pi over 6. Okay, so these ones don't work because if we plug it back in, you notice that it won't work somehow. Let's see. Oh, since square root of cosine 2 theta. So if we plug in pi over 2 and this, you get square root of cosine of pi, which is -1. And we don't like that. And same with 6 pi. Wait, 3 pi. 3 pi is also going to be negative. So we can't have that in our domain. So these values are deleted. And we're left with 4 angles. So at these angles is when it's the turning point. So we can plug those back in to x equals a square root of cosine 2 theta cosine theta. So x is going to be a square root of cosine of pi over 3 times cosine of pi over 6, which is, what's this, 1/2, so square root of 2 over 2 times 3 over 2. So a 6, 4. So that's the first x value. Second one is so that again is 1/2. Actually, you can just deduce since these are all, so if I just draw these angles out, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So along these is where the turning points will be. Now to find the y values, you could just plug it back in. Plug in y values for up here, and that's how you get the turning points of a lemniscate.